Good evening, everyone. And today we're going to discuss about race conditions in React using the library async-mutex. So we're going to take concurrency concepts to use it in the JavaScript world, and we'll see how it works and how it's going to help us in a real case scenario. And then before deep diving into the subject, I would like to introduce myself first. My name is Glodie Juvenal Pengele. I'm a software engineer. And I mainly work with React, C Sharp, and Go. And I'm a big fan of cloud technologies, especially Microsoft Azure. And also, I share videos about my journey as a software engineer, everything I learn, everything I discover, any topics I'm interested in. I just create videos and I share on LinkedIn and YouTube. But let's deep dive into today's subject, which is async-mutex. So one thing I like with my background is the fact that I work with different types of languages. I work with C Sharp and Go, and there you have a concurrency model. It's a part of the language. If you learn how to work with C Sharp and Go, you will like to go deep in the concurrency model. But on the other hand, I also work with JavaScript, which is a single-threaded environment. And in the JavaScript ecosystem, you will never hear about terms like semaphore or mutex because we don't need them there. JavaScript, the pure core JavaScript is single-threaded. So you will never hear someone talking about a mutex or a semaphore, which is normal. And we have a model, it's an asynchronous model, which works fine with us. If you have a code, you have your async wait, it works. But the asynchronous model has an issue when you're trying to coordinate them. For example, I'll give you a simple example. I have two requests. I have two components in my React application. When I mount my application, I need to send both requests at the same time. But I have the request A and the request B. But I would like to update my store with the response or request A before the request B. I need that coordination. But the issue here is if the response of request B comes first, maybe it will update my store. But it's not what I wanted. I need to have a mechanism or a process where I will tell the request B, you have to wait. I need to update the store with the response or request A first. But we don't have it in the asynchronous model. But that issue has been solved in the concurrency model. We have a mutex, but we don't have it in the JavaScript side. So on the one hand, we have the asynchronous model. On the other hand, we have the mutex, which is the solution of that problem. And if we put it together, we have the async mutex, simple solution. And if we go deep with the library, and you can see the statistic about the library, it has 6.7 million of weekly downloads, which means that it's solving a real issue that we have in the JavaScript ecosystem. It's used. More than 2,000 projects depend on this little small library. It uses TypeScript. You can use it on Node.js or in the browser. It's lightweight. You don't have to pay. It's free. It has the MIT license. But before deep diving into the subject, I mentioned multiple terms like semaphore and race condition. So I'm going to define them first so that I can clarify my point. So what is a mutex? Basically, a mutex is like a lock that will guarantee us to not have access to a shared resource. So here we're going to have three main components. And we're going to take a example of threads. I have two threads here, and I want to update a shared resource. You can imagine like a Redux store or a Zustan store, whichever you want. But here you take the example of a thread. And if I want to update my resource with thread A before, what am I going to put? I will put a mutex here, and I'll tell to the thread B, you have to wait until I'm done with the thread A. And then afterwards, you can do whatever you want. So this is the mutex. Simple, just you lock the resource, and then before updating, the other threads or requests are going to wait. And the mutex solves the issue of the race condition. And to make it simple, the race condition is when some operations the result of the operation depends on the time, not what you wanted. So here, simple example, I have two components, component A and component B. I send requests with both components, but here I want to update my store before the component B. But here, since the request A came first, it will update my Redis store before the request A. So this is not what I want. And it's called a race condition issue. So the result of the operation depends on time. I'm going to show you a quick example of a race condition issue. So here, I will just reset everything. So I have 10 parallel requests, and I want to update, which we're going to consider as a common store. And here, if I send without a mutex, I have 2, but I expect to have 10. If I send it again, I have 3, I have 4. So the response is not deterministic. And we're going to understand why. So for example, here I have multiple promises. When they're resolved, they're going to read the store and see which is the value, and I'm going to increment. So here, the first one is resolved. It will see the value is 0. The second one is 0, and the third 0. So the way to consider the value as 0 and to update to put 1. So both the 3 requests, they read the value as 0 and they put it at 1. And here, when the promise 4, 5, 6, they read the value, it was 1 and updated to 2, and then yeah. So by the end of my request, I have 3 instead of 10. I didn't use a mutex. But when I run it with a mutex, you can see I have 10. If I run it again, I have 10. All the time I have 10. It's deterministic. By the end of the request, I have 10 all the time. And let's understand how it works. So here, before updating a value, all the promises are going to wait for the first one. So here you can see the request 7 has been resolved in 29 milliseconds, but it's going to wait for the request A to update the value first before doing what it wants to do. So here, this one has been resolved even later than request 7. And it's deterministic. We're going to have 10 all the time. If I run with mutex, 10. If I run without mutex, the value just differs. So this is a typical issue with race conditions. Let's go back to the presentation. And then let's focus now on the library. So as I said, async-mutex is a simple library. It's a lightweight one. It has simple APIs. So here I can just import the mutex. I instantiate my mutex. And when I put like mutex acquire, it's like I kind of lock the concurrency, the asynchronous request. And until I run the release, it will mean that, okay, you can do whatever you want. But until I'm here for this asynchronous code, all this code will just wait until I'm done. Any asynchronous code will wait if I acquire with async-mutex has multiple APIs, but I'm going to give you 3 APIs that if you use it, you're going to rely most of the time. You have the mutex, which is the lock that's going to allow you only want to have the access to the store or the shared resource by only one resource. You have the semaphore, which is going to, okay, if you want to allow multiple concurrent requests to have access to the resource, for example, you want 3 requests to have access to the shared resource, you're going to use a semaphore, not a mutex. And then we have another API which is called with timeout. For example, you have your request and you don't know where it's going to be resolved. So instead of just running it forever, you can put a timeout, say, okay, after 3 seconds, if it's not resolved, you can just release the thread, kind of. It's not not blocking the thread. And we're going to focus on a real problem here, which is a token refresh. And I'm going to give you my use case that pushed me to discover the library and to use it. So in typical application, I have multiple components in React. And I want to do something automatically. So when I discover that the refresh token has expired, or the access token has expired, I want to refresh that token automatically to my API. So what's going to happen here? If, for example, the component A sends a request to retrieve data, and during the request, I can see, oh, the token has expired. What can I do? The component A, the request, will try to get a new access token with a refresh token. And then afterwards, you're going to update the store, which is my shared resource in my entire application. And then it will resend the previous request. But the issue here is when I have multiple components that are mounted at the same time. So all those components are going to try to send the same request because they will detect that the token has expired. So component A will send the request, component B will send the request, component C will also send the request. So I have 3 requests to refresh the token of my application. And then the first one that will come with the result will just update the store. And then the second one, and then the third one. This is a race condition issue. And I need to have a way to tell to all the components, oh, if there's one component that is refreshing the token, you need to wait until it's done, and then you can take the new refreshed token. I'm going to show you that the use case. For example, I have the refresh token here. So you can see I have an access token and a refresh token. If I run the component, I'm getting the result. If I run it again, I'm getting the result. But if I run the 3 components at the same time, I have the result because it's still valid. But as soon as I run them again, you can see here, both, they can't have the new access token because they send the request at the same time. And the first one, this one, has resolved it first, and the other one, they don't have a valid access token. So when they would send the request to the API, they say, oh, the token is no longer valid. And every time I'll do it, but the second one, if the token is still valid, they're going to have an error. So this is a race condition issue because I don't have a way to tell to other components, you know what, wait until I'm done, and then you'll get the new refresh token, and then you can send your request. So this is when the library will solve the issue. Oh, not here. So, yes. So how are you going to solve the issue with async-mutex? So every time I need to run the request to the API to say, okay, I need a new refresh token, I'm going to put a mutex here to tell to all the asynchronous requests, okay, you need to wait until I'm done with the refresh token, refreshing token. So component B and component C are going to wait. I will take the new token, I'll come back with it, I'll put it in the store, and I'll let it, okay, you can use the new refresh token. And if you go back to the application with a mutex here, if I run the component A, it's going to take some time, it works. If I run it again, it works. But if I run the 3 parallel requests, I have everything that is green. If I run again, I'm going to see I still have it's working. They are able to retrieve the data because when one component has detected that, oh, I'm refreshing the token, the other component are waiting for the result before sending the request. So this is how the async-mutex is resolving the issue. And we'll see in the code how it works. Yeah. So I'll show you. So this is like what, 10 lines of code that solve the issue. So here first I'm using a Redux toolkit query because it was easier for the presentation to have Redux and the query. But you can couple it with Tanstack query or whichever you want. But here I used Redux toolkit. You don't have to use Redux toolkit. You can couple it with any request library that you want. So here, the first thing I'll do, I'll use an API which called wait for unlock. So when I want to run a request, so I have in Redux Toolkit, you have a base request that you're going to use. For example, if you want to put a refresh token and access token, you're going to create a base request, and then upon it, you can just run everything you want. So it's going to be use this one. And here, when before starting my requests, I will check if there's a mutex that is already on. For example, is locking not the thread, but is locking the request. I will check, oh, is there any mutex that is there? If there's no mutex, I can just send my request. So I call the base query, I send the request normally. And then if I detect that, oh, it's a 4.1, which means my API responded like, oh, the token is no longer valid. What am I going to do? Next, I will try to see, oh, is any other component has the mutex? I will check, oh, is logged here? If it's logged, what I'm going to do, I'll wait until it's done, until the component that has the mutex is working on it with it. And if there's no component or no request that having the lock, which means that I'm the first one. So I'm going to acquire the token, which means I will take the mutex. I'll say, okay, if you have asynchronous code, you have to wait now until I'm done. And then here, I will just take the tokens. I will send the request to refresh the token. When I'll receive the response, I'll dispatch it to the Redux store so that it's available for all the other requests. And then I'll release the mutex. Say, okay, now if you want to have access to you want to send your asynchronous code, you can do it now. And then me as the first one, the first component to detect that, okay, I acquired the lock. I can now resend my previous request. Okay, I refresh the token. I can now resend the previous request, and it's going to be done automatically for all the components. I don't have to do anything. Every time I have 10, 12, 20 components, if I have one that detects that the refresh token is no longer valid, it's going to resend the request, refresh it, and then come with the result. And all the other components at that time are going to wait for the refresh token to be resolved before sending their request. So this is how it works, and it's quite simple, like what, 10 lines of code, 10 or 20 lines of code. You just have the system, which is scalable because it doesn't depend on the number of components that you have. If you have more components, all those components are going to wait for the refresh token to be done before sending the asynchronous requests. Yeah. So this is about async-mutex. But are we going to use it all the time? No. And the library has limitations and trade-offs. So first, the library will add latency. As we saw it, if I'm sending a request, all the components are going to wait. So if your API is quite slow, it's going to have an impact on the user experience because they're going to wait for all the first request to be resolved, and all the components will not send their own requests. And then afterwards, all the components will just send them. So if you're using async-mutex, you will need to understand that, okay, when you lock the resource, or when you lock the concurrent request, it might be a bit slow. And the second risk and limitation that we can have a deadlock risk. And you saw the release function that I called. If you don't do it, it means that all your requests are just going to be to wait forever until the user refreshes the browser. So you need to be aware of, okay, how you're acquiring or releasing the mutex. And to help us, they've created two simple APIs. The with timeout that I mentioned. So after time that you will define, it will just release by itself. And it also has the run exclusive API. So when you have it, even though after some after the synchronous code, it will just release by itself. You don't need to call it explicitly. But there are some use cases when you will need to call release explicitly, like in my case when I have to acquire and then to release. And then there's the library is no longer is not needed all the time. I mentioned that okay, it's something that is resolving an issue in the JavaScript ecosystem, but if, for example, you don't have a shared resource and you don't have concurrent requests that will update the shared resource, you will not, maybe you don't need to have to use it. And I'm going to give you few use cases when you might need the library. If you have, for example, the example I gave, the token refresh with concurrent requests, yeah, probably you will need to have it so that only one request is going to update the refresh token. All the other requests are going to wait for the request to be refreshed, the token to be refreshed. And another use case that you might need it is if you're automatically saving a form to the backend, and you don't need another request to overlap, and you just need, okay, the first one to be saved, the second one to come after. Maybe you're going to put a mutex. Okay, when I'm saving the previous request, all the requests are just going to wait, and then I can order and say, first in, first out. And you have the way to control which request comes and which request just goes out. But when you don't need to have the async-mutex, if you have independent parallel API calls, for example, just sending the request that you don't have any mutation, you don't need to have it. You just lock your I don't want to say that you're going to lock the thread because it actually doesn't lock the event loop. It just has another way to do it, but you don't need to have it if you have independent parallel API calls. And also, if you have only read-only data fetching, that's you don't update any shared resource, you don't do anything, you're just sending requests, you won't need a async-mutex library. And I can give a simple rule to, I think, to use if you're wondering if you need the library or not. If you have concurrent requests that are going to update a shared resource and you need to order or the order matters for you, you might need to have the async-mutex. If not those cases, maybe you're going to put more problems than solution in your application. So this is what we need to remember when maybe you might need to have the async-mutex. Even though it's solving an issue in the JavaScript ecosystem, it's not solving all the issues.
Yeah, we could have done very choose mutex over semaphore.
Yes, you can do semaphore. Yeah, exactly. Yeah, and I think this is where I'm going to wrap up. If you have any question, merci before the question. Any question? Yeah.